next capability we're going to talk about is studying cause and effect. Now, we choose the word studying cause and effect versus finding cause and effect because it's about how we approach it. The word study is important. We want you to be a student, be a learner, be curious about cause and effect. To me, this is almost the centerpiece of good, solid problem-solving thinking, is that curiosity of cause and effect. Thousands of years ago, in the creation of the concept of scientific method, some of the key words that came around this were things like observation, experimentation, accuracy, intellectual rigor. And that's fundamentally what we're talking about, is the scientific method. Really, how do we explore and understand and observe cause and effect? Now, direct observation is perhaps the most important element of this. This is not just whether we use our eyes or not, but how do we go get the real truth, the real facts, the real observation? This means that we put aside our bias and our assumptions when we start to go study why something exists. Why is something the way that it is? What could have caused what happened? When we start to do this, we put aside our bias and approach it with a truly neutral viewpoint. We also need to understand sort of an organizational filter around how we put together what we see. You know, if you were going to observe cooking, for example, you might look at the ingredients, the preparation, maybe the process of how you combine things, maybe the cooking itself. And so there's techniques, there's elements, there's a way to break down and organize the information of that observation. When we're looking at process, we often look at activities, connections, and flows. 3 building blocks of pretty much any process. No matter what tool we use, those are the sort of organizational elements in which we're looking at things. So this is where, you know, many certain fields of study, whether it's medicine or engineering or marketing, sort of provide you that organizational framework in which to put the pieces of observation together. But before you observe, you kind of have to know, how are you going to assemble what you're observing? So once you observe, you start to gain insight, start to gain understanding through your observation. You really want to understand what is the knowledge gap that you're closing. Fundamentally, this is a key part of problem solving. If you already knew the answer, you have an execution problem. You don't actually have problem solving to do. You are just taking a solution out of inventory and applying it to the known problem. Problem solving is where we don't know the answer. We, by definition, have a knowledge gap. And if you really want to do good problem solving, no matter what tools you use, you have to ensure that you are making efforts to close the knowledge gap before you close the performance gap. That is the key practice. Close the knowledge gap before you close the performance gap. Now, there's 2 key questions that set you on the right path to do this. First, define, what do I not understand about this problem? When most people take out a problem-solving template and they get to some place on the tool where they would capture current state, most people start to capture what they already know. But it's not generally what you already know that's going to hurt you, it's what we don't know. And so we ask ourselves, what do we not understand? What do we not know about this problem that we have to go understand better? And then second, what is the best method to go learn? Right? So this is where we actually start to get to select a tool or an approach. It may not be a tool. Sometimes we just go ask somebody. Sometimes we just go observe. But there's many tools that we can use, from 5 whys to fishbones to process maps to interviews, all sorts of tools to help us understand cause and effect. But we want to make a good choice about what we choose to go study. Right? Now, it's important to understand the difference when approaching a knowledge gap between a discrete knowledge gap and a continuous knowledge gap. A discrete knowledge gap is one where there is an answer. Right? What is 2 plus 2? Why did that circuit breaker fault? Right? These are things that generally have a cause. They have a answer. And so we are in the pursuit of that specific answer, that discrete answer. Then there's continuous knowledge gaps. These are ones where either the target is always moving or it's perhaps unknowable. There's a range of answers. Right? How much is our customer willing to pay for that product? There's not one answer for that. There's probably a range of answers to that. And that answer probably changes over time. Right? And so understanding, are we looking for discrete knowledge or continuous knowledge, helps us decide what tools or methods we're going to select in the pursuit, and also helps us determine when we're done. Because quite frankly, with continuous knowledge gaps, we're never actually done. We have to define how much confidence we need before we're ready to proceed. Now, most importantly, as you approach this, it's going back to what I started with, which is be curious, be a learner. That's what we're trying to do in studying cause and effect. It's not a race to the answer. It's the pursuit, it's the rigor, it's the effort to find the answer. And if we have to spend more time in that curiosity, in that learner's mindset, the rest of our problem-solving efforts will be that much better as a result.